Welcome. I'm Dick Brandt, the chairman of the Logan Clay Products Co in Logan, Ohio. We're glad to have you with us to learn more about our company, the products we make, and the incredible jobs that our employees do each and every day to make an exceptional product that's used throughout the United States.
Clay pipe manufacture came to Logan in 1876 when William M. Bowen organized the Logan Fire Brick and Earthenware Company after making some tests of Hocking County fire clay. He became president of this organization. Mr. Bowen in 1871 had laid out the Bowen addition for the city of Logan and for the purpose of starting a clay industry. Deeded to the company, 15 of the lots created in this addition. These lots are the place where the company is now located. On January the 4th, 1904, articles of incorporation of the Logan Clay Products Company were filed. In 1905, the newly formed Logan Clay Products Company purchased the assets of the Hocking Clay Manufacturing Company for $150,000. The new owners must have been converting to the manufacturing sewer pipe, wall coping, flue lining, and chimney tops very soon after taking over, as their 1912 catalog showed a complete line of these products that made no mention of the formerly produced building materials.
The Logan Clay Products Company in 2019 has a remarkable 129-year history. One reason for their success is their ability to take their proven product line and then introduce modern technology as it becomes available to the production process itself. The durable, corrosion-resistant vitrified clay pipe manufactured today by the legendary Logan Clay Products Company in Logan, Ohio, builds on the benefits derived from over 3,000 years of history using clay as the preferred vehicle for carrying away waste from our homes. Logan Clay Pipe also incorporates advances in ceramic engineering and technology to produce the most durable sanitary sewer pipe you can specify or install. In addition, they offer a complete line of flue liners and several specialty products as well. Let's take a look at just how Logan Clay's outstanding products are made. It all starts right here. This is the Logan Clay Products Company's primary source for clay and shale, and it's located near Webb Summit, just a few miles northeast of Logan. Here we see clay and shale being loaded for the short trip back to the plant where the process will begin. When the clay and shale from the mine arrive at the plant in Logan, it comes first to this grinding room. About once every 2 weeks, around 700 tons of the material are brought in. In addition, dry scrap clay from the manufacturing process is added as needed to reach the right moisture level for pulverizing the material for use. After passing through this primary crusher, the clay and shale are transported by conveyor to a holding area. clay and shale are loaded through this Mako feeder, which distributes the material onto a conveyor belt. Next, it passes under a large magnet to remove any metal scraps. Barium is also added to the mix at this time to ensure a clean red finish on the final product. The mix then travels through a hammer mill to be pulverized to the right consistency before heading up the conveyor to the filtering screens. This ensures that the mix is just right for the production process. During our visit, we watched as 24-inch no-dig pipe was being extruded and finished. A pud mill receives the processed clay and shale by overhead conveyor. Water is added, and then augers push the clay through a die to form the pipe. Here we see the former cap suspended from overhead. After the former cap is locked in place, clay can be seen exiting the cap as the pipe socket is created. The cap unlocks, and then the barrel of the pipe is extruded. Here the pipe is being trimmed to length by cutting 2 rings at its base. The rings will be removed after drying and before the pipe is fired.
All the dryers on this side in plant 1, which is where we're at now, are batch dryers, which means we fill the dryer full of product, close the doors, and each program, be it 12-inch pipe to 24-inch pipe, has its own drying program. Once we light the dryer up, it automatically progresses whatever program we set it at. I have kill firemen here 24 hours a day, 8-hour shifts. They monitor the temperature of the dryers, and as the dryer gets close to being complete, this drying cycle, we put small nails in the pipe that are close to the exit doors, and we can come in halfway through the drying process and prong those nails, and that lets us know the percentage of moisture left in the pipe. We don't want to dry the pipe completely bone dry, let's say less than 2%. If we dry it less than that, we're wasting our time, because atmosphere, you have moisture, you dry them all the way down, the pipe then reabsorbs that moisture, so we're just wasting energy, and it causes some bad problems with the pipe if we let it absorb too much moisture. So They'll check the pipe prior to shutting off. We'll shut the dryer off, and within a day, we'll set these pipe in kilns and get the firing process started. All these pipe, anything we produce is basically clay and shale, 30% clay, 70% shale. We add grog or bitten back to the pipe. It's on a separate belt. That helps to open the body up of the product to help it dry, give it strength, and also control shrinkage. If we do not shrink the pipe properly, then they won't fit the molds in the joining process or the grinding process for no-dig.
Here we're watching the same process as on the 24-inch pipe, but this extruder is producing 6-inch, 2-foot pipe. The former cap goes in, the clay is extruded, and the pipe is cut to length. It then rolls to a finisher where the ends are cleaned and the company ID and production date and information are embedded in the wet clay. An example of incorporating new technology at Logan Clay is this new kiln. This 40-foot diameter kiln is of all steel construction with a fiber lining instead of traditional fire brick lining. The fiber lining heats faster and cools faster, which means quicker turnaround times for their products. Here we see a variety of pipe product now at the proper moisture level after drying has been completed, being loaded into a kiln for firing.
All the way around the kiln, you'll see these burners. There's 10 burners. The burner hits the deflector, goes to the top of the kiln all the way around. The heat is thrown to the top and then brought down through the wear. In the center of the kiln is what we call a well hole. It's probably 8 feet deep by 4 feet wide. That well hole takes all the fire and combustion products out to the stack. We control how much we pull by lowering and raising the damper. In that well hole, up halfway, is a series of smaller tunnels that pull the heat evenly throughout the kiln. Then that goes to the big tunnel, which takes it out to the stack. What we're looking at, these are what we call the controllers. These tell you the bottom temperature, top temperature. The controller on your right holds all the programs. The programs are infinite. We can put in 5,000 programs, but we only have programs for 8-inch burn, 10-inch burn, 12-inch, 15, 18s, 21s, and 24s. Now, as you're looking at a controller, the controller on your right is the top temperature of the kiln. The controller on your left is bottom. Once the kiln firemen light the kiln, they'll flip over a tab it'll be yellow. That lets everyone know that walks into this office immediately which kilns are burning. So these kilns are in the firing process. Kiln number 8, which is kind of right outside the door, is at its top temperature, it's 2,000 degrees. That is our top temperature we fire our kilns to at this time. It's based on your shale and clay mixture, and to get the proper crushing strength, the absorption of the pipe, the shrinkage of the pipe, we're now firing to 2,000 degrees. Everything we do is governed by ASTM. We must exceed or overcome any ASTM specifications for crushing, dimensional checks, and so forth. So every time we fire a piece of a kiln, a percentage of those pipe are taken from the kiln, taken to the lab, and then measured and crushed and tested and documented. All of our pipe, and I didn't cover this very well in the press room, we hand stamp, or if the pipe are made on a different press, they roll down a table, and in that pipe is embedded a Logan Clay Products label that says Logan Clay Pipe Extra Strength Full Diameter Pipe. And on that is also a date code. So with that, we can tell when the pipe was produced, what day, what week, what month, so forth. And if we have an issue, we can go back and look at those records. But as you see, we have 11 kilns that are burning. The blue signifies it's in the cooling process. So at this point in time, this particular kiln is 419 degrees. It's not burning. We are cooling it down so that then later next week, the gentleman can get in the kiln and draw the pipe out. The computer is more of a ride-along thing. It's not controlling the kilns. I can shut the computer off. These program Yokohama controllers are doing the actual work. These are a means of recording and documenting for further down the road. One thing we also do is a handwritten check. So every hour, every kiln has its own paper, tells it what's in the kiln, and then my fireman will check top temperature, bottom temperature, how close is it to the schedule. They'll go out and physically look at the kiln and look at the gauges, make sure the air is set properly, the gas is set properly, the pressure in the kiln is correct, then they'll record it here. So that keeps everybody on task. If you sit back and rely on just looking at a number, you don't get everything we need to have done. So the guys do that for us.
Here we see a kiln being fired at 2,000 degrees. A series of cones are placed just inside the door in line with inspection ports that indicate to the kiln fireman just how close this kiln is to being finished. Here we can see those indicator cones in the foreground in this kiln that has completed the firing process and is ready to be unloaded. Here pipe is being unloaded from a kiln following the firing process. A sample from each firing goes to the on-site lab for quality control testing.
My grandfather, Barton A. Hall, came to work here as a salesman in the 1930s. In 1950, he bought what was then controlling interest in the company and was here throughout the rest of his life. His two sons, Bart and Dick joined him shortly after his assumption of ownership of the company, and they were here throughout their working lives. I joined the company in 1968, so I've been here about 51 years. My son, Rudy, is the current president of the company, and we look forward to a long future with the company and in maintaining the success that we've had over the many years of its operation.